Folks, this video I'm ultimately making to ensure that if you're not able to attend the session, this can help you to get back on track. As I'm keep insisting, the actual session, actual live session, detailed explanation is always at very high priority. This can help you to get back on track. Going forward, will not give any such short videos to get you back on track. It's completely your responsibility. If you miss the bus, you miss the bus. All right. If you're missing any kind of a sessions, you're already missing it. We're trying our level best to make it on track. I know you might have personal reasons, but learning has to go on, whatever the reasons it is. So kindly consider this weekend you have a project work and starting phase 2 next week, and the placement work is going to start. At this point of time, if you give any gap, that doesn't help you out. So complete this video. It's hardly going to be 40 minutes to 1 hour video, so that you can be on track and attend this week's session. We have project work as well as AWS Hive Analytics in this weekend. So kindly take this as a help. Don't take it as granted, this video, and do not skip sessions going forward. It's not acceptable. Going forward, there is no short videos like this I'll be providing. This is the last. Fine. Now, with respect to Hive introduction, we have seen some of the topics, right? With respect to what is Hive, what is HQL versus SQL difference we saw. Then we saw Hive warehouse, location, types of tables. Now we saw Hive is an SQL on top of HDFS, and even though that looks like SQL but not SQL, but back in the MapReduce runs. And we saw SQL and HQL. SQL is a database. HQL is a data warehouse. SQL is an ETL purpose. HQL is a ELT purpose. SQL is a load time parsing. HQL is a query time parsing. SQL is only for structured data. HQL is for structured and semi-structured data. Hive warehouse. We saw Hive has its own personal room. If you create any database, there is Hive, we have personal room, where if you create any database, a directory gets created. If you create any table, a directory gets created without location. That we saw. Right? Now, last week we saw two major topics. All right? Types of tables and partitions. And we also saw location, right? What does the location mean? So I can able to, if I imagine I have a Hive table. If I create a Hive table, this is your Hive shell. I'm just creating a directory, imagine, right? For example, Kdir. I'm creating a directory in HDFS, and I'll put a file. Hadoop fs -put t file user cloudera Kdir. Hope you remember the location. I'm just showing it. So what I did, I just created one directory. Something known as Kdir. Right? To this Kdir, I put a file, something known as T file already. The file is sitting inside. Right? The file is sitting inside. I created a directory known as Kdir and I put T file. The file is sitting inside. Now, we have an accessibility to create a table on top of the directory. Hope you know that. Right? If I am about to create a table, imagine create table ktab id int name string row format delimited fields terminated by comma, right? Location. Hive table is waiting for a location actually. It is about to get location actually. It is waiting for a location to be given, right? If I don't give any location, obviously it creates in the warehouse. In the name of, it creates a directory. But Hive tables expects a directory actually. Hive table expects a directory, right? So if I don't give a location as a directory, it directly goes to the warehouse and create the table. But I can point this table to this directory. Yes, this is possible. Now, if I give the location user Cloudera kdir, a table directly go and point towards this directory. That's the reason a table got created. If you query the table, you see the data coming up from the directory. That's what we saw as a location. Now, in today's this video, we are going to see two major topics: types of tables, partitions. In partitions, we are going to see static partitions, static insert partitions, dynamic partitions. This is the major topic you're going to see. All right. Just have a check. Let's have types of tables. All right. Now it's a pretty important. The types of tables are very high priority in our real time. In Hive, we have two types of tables. I'll tell you the difference. All right. Let's start with types of table, folks. In real time, in Hive, we use two types of tables. But there is one major difference and one major use case where we go with types of tables and its necessary use. Now, let me just take you through the types of tables. Before that, let me just make the data ready for you so that we can work upon types of tables. Just give me 1 minute. I'll just make the data ready for you. Now, let me just take you through one of the scenarios. Let's check HDFS what we have. Let's check HDFS what we have. Sorry. We have two directories. Both the directories have the same file. It has T file. This will also have T file. Both the directories have the same file. Now, let's go to let me tell you in the this location. So folks, let's target types of tables always partition and we can close the video. See, have a check. We have HDFS. In this HDFS, we have two directories, mdir and edir. And edir. Now, in this mdir and edir, I have data sitting inside. Same file, that's okay. The file is same. Okay. Same mdir and edir. Now, with respect to this mdir and edir, all right. Now, if we want, let me talk about this scenario. Let's create a table on top of this as mtab. Let's create that first. With your knowledge, create table mtab, id int, name string, row format delimited, fields terminated by comma, location, user Cloudera mdir. It's a pretty straightforward table creation. Yes, table is created. Now just query the data. You will see the data coming up because the table is directly created on top of this directory. Now, let's describe this table. Yes, mtab is created on mdir. Mtab is created on mdir. Pakka. Now the data is ready for you. This table is created on top of mdir actually, right? This table is created on mdir. Now, what happened? All of a sudden, I'm dropping this table. Drop table mtab. What I do? Drop table mtab. So by dropping the table, let's see whether it will impact this directory or not, because we doesn't know. Let's see. If you do Hadoop fs-ls, let's see whether the directory exists. If you see the directory is gone, by the time you drop this table, the directory also gone. The reason, the table which you created here is a managed table. Managed table, right? Since it is managed table, right? That by the time that you drop the table, the directory gets deleted. I'll tell you where you can see the managed table. Some time ago, we have describe formatted mtab, right? There you'll see the location as well as the type of table. We call it as managed table. This we call it as managed table, right? That's the issue. If it is a managed table, if if you drop this table, the backend directory gets deleted. Right? So how to tackle the situation? All right. Let's create another type of the table on top of edir. Now, the another type of the table which we are going to create, right? Let's create etab. Let's create a table known as external table. Let's execute the same table, same execution with external table. Another type is external table. Create external table, etab, id int, name string, row format delimited, fields terminated by comma. Location, user Cloudera, edir. Now I'm creating etab on top of edir. Etab is getting created on top of edir. Now shoot the command, you will see etab. A table should have got created. Now the table should have got created in the name of table, external table. Now if you do describe formatted of etab, you will see the directory is created on edir and the type of table is external table. All right. Now, if you drop table etab, all right. If you drop this etab, only the table gets deleted, but directory stays back. But directory stays back as an edir. The major advantage of this particular edir is, external table is, we use it for the target analytics table. What is target analytics table? Imagine if analytics is performed on some tables, right? We should be at high on risk. If we create a managed table, this entire data gets affected if we drop. The only difference between managed and external is if you drop the table, the backend directory gets deleted in managed, but in external, the directory stays back. So this is a total differences between managed and external. Managed tables, we predominantly use it for the stage data processing. See, some data got imported to this location. I want to process this data and write it to a target location by creating one table on top of it. Once the processing is completed, we can drop it so that memory can be utilized. So here we stage data processing. In between intermediate data processing, we use managed table. But the target systems, we go with external because if I create a manage, it would be high on risk. This is types of tables for you. It is pretty important. All right. It's pretty important. I'll give the hands-on doc, practice it. Okay. Folks, the next topic is very, very important. It's going to be Hive partitions. Trust me, it's very, very, very high priority right now, right? Let's get started. Fine. Now, let's talk about partition a bit. All right, folks. This topic is very high priority actually. See, Hive partitions at very high priority. The reason partitions is not a Hive topic. Partitions is a global topic. Hive partitions. Okay. Partitions is not a Hive topic, folks. It's a global topic. So, how partitions are used in Hive? What is actually the partition mean? All right. Let me just give a brief about what is actually a intro about Hive partitions or just a partitions. Now, here, as partitions are concerned, just imagine this way. Imagine we have two tables. Folks, very important. Please have a check. Partitions are very, very high important. Please have a check because there is no project without partitions. Partitions is not a topic of Hive. It is a topic of Spark, Cloud, and everything. Kindly be on time. Kindly be remembering on that. So imagine I have Hive partitions. What is Hive partitions? See, partitions is predominantly used for performance tuning. Why we go with performance tuning? Let me tell you that. Any kind of a project, we predominantly expect the query time should be faster. The analytics should be faster. The result should come up very faster. So that's the reason Hive partitions or partitions came into picture. Partitions at very high priority, have a check. Imagine I have one table. How partition can enhance the performance? I'll tell you that. Please concentrate. Imagine I have two tables. Table 1, table 2. Right? Now, I have 10 million India data. Imagine that. 10 million UK data. Imagine that way. 10 million US data. Imagine that way. All right. This is a data size you have. All right. Total data size. Now, if you check this table, if I have a table on top of this, and if I shoot a query, select count of Indian records, then the major problem here is it will scan the whole 30 million data to give this 10 million data. Folks, in this short video, I cannot detail on it like weekend. That's 100% of the issue. But best in worst. That's it. Okay. But if you want to get a detailed explanation, go and watch the actual video. But that's the reason I have been hitting my head and telling you not to skip any sessions. This will help you in the worst case. That's it. But it will not give a detailed understanding. But this can help you to fill a gap immediately. But never ever have a thought to skip sessions. Let's go in a high level. Okay. If I do select count of India, all right, now the whole table will be scanned. That means the total scanned is 30 million. The total scanned is 30 million. Result would be 10 million. Even though I'm counting only India, and India is the only guy I'm just expecting to take account. If it is a very normal table, it scans 30 million, the whole table it scans unnecessarily. Right? This is a normal table issue. Now let's talk about, imagine if my table is a partitioned table. Partition is nothing but sectioned, divided, separated. Right? Imagine this is the partitioned table in the right. What is partition table? Just imagine this way. All right. What if my India record is partitioned on the other end? What is partition? If every country is partitioned, All right. As like this, 10 million, 10 million separated. India records are separated. UK records are separated. US records are separated. In this case, imagine, I'll tell you the folder structure, how that works later at the backend, but partitioned, it's nothing but separated or segregated. If I shoot the same query at the backend, select count of India, ultimately, since the data is already partitioned, because if I shoot a query equal to India, all right, it will scan the whole 330 million data. So, right? But if I shoot the same query with country equal to India, select count of India where country equal to India, it will only scan this record, particular particular section of data. I'm increasing the performance here. Here I'm scanning the whole 30 million and taking only the certain amount of data here. But to take the 10 million, I'm working on 30 million data. But here, in this case, I'm just working upon scanning only the 10 million data to take the count. So if you see the same report here, so I'm scanning only 10 million data and results will be 10 million. So I'm increasing the performance. I'm not scanning the whole table. That's what we call it as partitioned data. What is the difference between the partition? In the left table, I have a country column. It is not a partitioned or sectioned or divided. All the countries there in the same table. In the second example, the data is completely partitioned. India data is separated, UK data is separated, US data is separated. I'll tell you another example. Let me show you two tables here. The best example I can show you, two tables. Folks, have a check. This is quite important. I'll show you two tables, a normal table and a partition table. Have a check. It's very, very important. I have two tables, N tab and P tab. Okay. Now have a check. Now select star from N tab. Select star from P tab. See both the tables. N tab, P tab. N tab is looking like this actually. This is your N tab. And this is your P tab. This is your P tab. Both tables are looking so similar. No much change. Everything, the data is same. Maybe like the data is looking same, like 6 rows, 4 columns, 2 India records, 2 UK records, 2 US records actually. The table might look same, but N tab is a normal table. P tab is a partition table. My gut feel is N tab is a normal table, but P tab is a partitioned table. Actually, India records are partitioned, US records are partitioned, and UK records are partitioned. Now, here, this is partitioned at the back end, but in our front, it may look normal, but it is partitioned at the back end. Let me show you that. See, my gut feel is N tab is a normal table, but P tab, the data is divided at the back end as a India country wise. All right. How can we check that? How can we see the difference between N tab and P tab, even though the data looks same? Let's go to the backend directory. Now let's go to describe formatted N tab. Now with this particular N tab, I see the table is created on top of NDIR, right? To this N tab, I create a table known as NDIR. Let's go back and check what is there in this particular end tab. All right, let's go back. This is a hue, folks. This is a hue actually. All right. So this hue will give you a representation of HDFS, user Cloudera. You can check in the backend also, but this gives a better understanding initially, but hands-on, you can check the backend itself. Now, user Cloudera, this is ender. If you see, I have only one file. In that file, I have the whole table data sitting. It's not a partition, it's a normal data. Inside ender, I see only one file sitting. All the 5 records are sitting in a single file known as allcountry.csv. The entire data is sitting in a single file known as allcountry.csv. Right? This we call it as n tab. Yeah, is sitting with one under on top of ender with allcountry.csv. This is what we saw right now. But let's see what is the difference on p tab. If you check the difference on p tab, if you go to pdir, you will see the sectioned data, divided data. See that? Country equal to India. I'll see India TXNS. Only India TXNS will come. If you go to country equal to UK, UK TXNS, only UK TXNS will come. If you go to country equal to US, US TXNS, only US data will come. So data is sectioned and divided at the backend. Imagine my table is created on top of pdir only. This is my table created on top of as pdir. But by the time I shoot a command, select count of pdir, ptab. Okay. If I create a table known as select count from ptab, where country is equal to India, right? I'm referring here, hey, country equal to India. Here itself, I'm referring it. All right. Now, straight away, it will go and point to this directory. So it will directly go and get the data from this directory. Because my table is created on top of pdir actually. When I take count of ptab where country equal to India, directly the data goes and take this data. Only I'm not scanning the whole data, only certain portion of data I'm scanning. We call it as partition. Partition are nothing but folders inside. Partitions are nothing but folders inside. Right? So n tab, straight away all the data is in a single file, but p tab has a section data at the back end. Partitions are nothing but folder creation. Partitions are nothing but folder creation. Folders. Partitions are nothing but folders. This is what we call it as a partition. All right. Every India data has a separate folder here. For UK data, I have a separate folder here. Correct? For US data, I have a separate folder here. This we call it as a partitioned data, separated data with respect to the folders. This is an intro on partition. Just a quick recap. If you take this example, if I have 10 million India records, 10 million UK records, and 10 million US records, if you are doing a count of country equal to India in the left example, it will scan the whole 30 million data to give you the 10 million count. But at the back end, if you take the partition table, if the data is separated, partitioned, section, divided, India country-wise, if I shoot a query, select count of India where country equal to India, it obviously scans only the required data. That is what we call it as a partition data. The best example is this one, which I just showed you. This is a partition introduction. Now, let's talk about execution, right? Let's talk about execution. Let's talk about static load partition. Folks, it's pretty simple. Please bear, almost done. three examples and we're wrapping up, right? We got one requirement. My boss has stated a requirement, stated that, Sai, you have three files sitting in edge node, India TXNS.CSV, UK TXNS.CSV, US TXNS.CSV. All right. India TXNS.CSV, UK TXNS.CSV, US TXNS.CSV. We have three files in this particular edge node. Create a partitioned Hive table with country as partition with normal columns, ID, name, and check. All right. Let put it this way. Normal columns, ID, name, check. Partitioned, create one partitioned column, country. Then, okay, what he's saying, you have three files in edge node, UKTXNS, UKTXNS, and USTXNS. Create a partitioned Hive table. Normal columns are this, partitioned columns are this. Now, what he says, okay, let me show you in Paint what he's saying. He's saying, you have an edge node, you have HDFS. In edge node, you have three files. India TXNS.CSV, UK TXNS.CSV, US TXNS.CSV. What he stated. We have totally three files in our edge node. First is very clear on his point. You have three files in our edge node. Then what he asked, create a Hive partitioned table, or imagine the directory name is zdir. Imagine the partition, the table name, the directory name is zdir. On top of zdir, imagine on zdir as ztab. All right. Or let's create one unique name. Okay. PP tab on ppdir. Let's a little bit funny. ppdir with pp tab. So this is ppdir. Create a directory known as ppdir. On top of it, create a ptab table. pptab table. But what is this pptab table? He's asking, create a partitioned table for which, have a check here, folks. Create a pptab table. Create a partition table with ID, name, and check as a normal table, I mean normal columns. Country as a partitioned column. That means he's asking us to partition this table and directory with country as a partitioned table. This is partition table. We are maintaining one column as partitioned column. All right. So this is pretty important. What he's saying, Sai, you have three files in EdgeNote, that we are clear. But on the HDFS, create a directory ppdir. On top of it, create a table known as pptab with ID, name, check, and country. Country as a partitioned table column. Now what he says, now load India TXNS.CSV to this table with partition name as India. Load UK TXNS.CSV to this table with partition name as UK. Load US TXNS.CSV right? To this table with partition name as USA. That's what the requirement states. Load India TXNS to this table with partition name as India. Load UK TXNS to this table with partition name as UK. Load US TXNS.CSV to this table with partition name as USA. What he says, now load this India TXNS.CSV. Load this India TXNS.CSV to this table with a partition name as India. Now load UK TXNS.table to this directory as UK. Load USTXNS, right? .csv to this table as USA with the 3 partitions. That's what he says actually. This is static load. He was very clear about his particular statement. Create a partition table. Load you with normal columns as ID name check, with a partition table and the column as country. Load India TXNS.csv as India. Load UK TXNS.csv as UK. Load US TXNS.csv as USA. Right? Now, let's target on creating this ppdir first. Let's flush everything, whatever we just created right now. Completely blank. As of now, it's completely blank. We don't have anything. All right. Now, let's create a directory. Let's go one after other. Hadoop fs-mkdir, user cloudera, ppdir. Now I'm just creating one blank directory here. The directory name is ppdir. Done. Now create a Hive partitioned table as pp tab with normal column as ID name check. All the hands-on documents will be provided. All right. Please practice it accordingly. With a normal column as ID name check, with a partition column as country. How to create such Hive table with ID name and check as a common column and country as a partitioned column. Now have a check. Create table pp tab ID int name string check string row format delimited fields terminated by comma location but sorry, 3 are normal columns, right? And ID name check is a normal column, but country is a partitioned column. All right. Now have a check. ID name and check is a normal column. Country is a partitioned column, partitioned by country string. This is normal column. This is partitioned column. I'm creating user Cloudera on ppdir. That's it. Table created. First, what? That's it, folks. ID name and check. It's a normal column. Partition by country as a partitioned column. Now, what happened? First, I created a directory. Then I created a table with the 3 columns as a normal column. ID name check and country as a partitioned column. This is how you create a Hive table. I'll give the hands-on commands also. Don't worry. This is your Hive table. Now if you go and check the backend directory also, this ppdir, the directory looks normal. Let's go and check ppdir here. If you see ppdir, so far it is normal, no data loaded. No data loaded. So if you want to start loading the data, load data local in path. Now it's time to load the data, folks. Now the data is there in Edge node, and I created the Hive partition table ready. Load data local in path, home, home Cloudera P like India txns.csv into table pp tab. And when you load it, you cannot simply load it. All right. You have to give partition name country equal to India. Now, what am I doing? I'm loading India txns.csv to this pp tab with a country equal to India. Now have a check. India txns. I am loading this particular data to this table, right? To this table, to the table pp tab, India txns to pp tab with partition name as India. Then I'm giving the name as India. Now let's load it. The data gets loaded. My gut feel is India should have come here with a partition name as India. Now let's go and check at the backend. A subfolder should have got created in the name of India, and I'll see India TXNS sitting. Now, if I query this table, select star from PP tab, you will see data coming up. These three columns are coming from the file sitting inside. I mean this one. Files inside, but this India is something coming from here. Partition name from which the India column is coming up. Similarly, I load USTXNS. Folks, all the documents, hands-on documents I'm giving you, don't worry, all right? You'll get along with the commands. UKTXNS. I'm loading UKTXNS file to this table as UK. Have a check. Now I'm loading UKTXNS file to this particular table with the directory name as partition name as UK. Now I'm loading USTXNS file to this particular table, all right, with the partition name as USA. Let's load it. Now I'm loading USTXNS to this table with the partition name as USA. That's it. 3 files loaded. While I'm loading India TXNS, I give partition name as India. While loading UK TXNS, UK partition. US TXNS, USA. Now, if I go back and check this particular location, I'll see all the 3 files. Inside India, India TXNS is sitting. Inside UK, UK TXNS is sitting. Inside USA, US TXNS is sitting. Now, if I query this particular table on top of this directory, select count of pdir, like count of ppdir, right? Where country is equal to India, then directly this points to this folder and it will take the count. This is static load. So as per the requirement, my boss is very clear. You have 3 files, create a partition table, normal column, partition column, load India TXNS as India partition, UK TXNS as UK partition, US TXNS as US partition. This is what the partition is. This is the one among the types of partitions. The commands are also ready. All right. I'm be giving the static load partition commands for you. You can practice it. Now, let's go with the 2 other scenarios. It is pretty simple. Have a check. Have a check. Now, my boss has put another mail. Okay. My boss has put another mail. What he stated. Sai, let's talk about, folks, I'm flushing out this whole table. I'm flushing out this whole table. As of now, I'm removing all the partitions for now. Okay. We're going to use the same table for our practice. Let's remove this whole partitions right now. All right. Let me have this. Fine. Now the table and directory is ready, the target. But this time my boss came up with a different scenario. What he asked, have a check. Sai, we have all country.csv sitting in edge node. Consist of all country data. See what he comes through. Before, I used to have 3 files separately for country. But this time, we have all country data with all country data sitting, right? This is all country data, right? What he adds up a point, this time, before it was just 3 files separated India wise, UK wise, and US wise. But this time he says every data, we got only 1 file this time, but it consists of all country data in a single file. Let me show you. Cat all country.csv. You will see the entire before it was India separated, UK separated, and US separated. But this time the entire data is sitting in a single file. Now let's go with the requirement. He says, we have all countries.csv sitting in edge node, consist of all country data, right?